According to Sheffield School of Aeronautics, flying is the safest mode of transport. Any certified flight dispatcher will also tell you so. It is the fastest too. What are these innovations in aviation industry that contributes to its modernity, safety, and speed? Let's explore the 10 most significant advancements in aviation industry. The first one will surprise you. As we continue, please like and subscribe if you love the content. 10. Airfoil. This makes the aircraft to fly. Birds, bats, and butterflies have them. Daedalus and Icarus donned them to escape Minos, king of Crete. We're talking about wings, of course, or airfoils, which function to give an aircraft lift. Airfoils typically have a slight teardrop shape, with a curved upper surface and a flatter lower surface. As a result, air flowing over a wing creates an area of higher pressure beneath the wing, leading to the upward force that gets a plane off the ground. 9. Propeller. A propeller functions like a spinning wing, providing lift but in a forward direction. They come in a variety of configurations, from 2-blade, fixed-pitch propellers to 4- and 8-blade models with variable pitch, but they all do the same thing. As the blades rotate, they deflect air backward that in turn pushes forward on the blades. That force is known as thrust and works to oppose drag, the force that retards the forward motion of an aircraft. 8. Jet engine. Its design and development began in 1939 when a British inventor and engineer named Frank Whittle tested the world's first jet engine. It was then adopted by British government during World War II. Today, they are primarily used by commercial planes worldwide thanks to their efficiency and less noisy. 7. Jet fuel. The adoption of kerosene-based jet fuel revolutionized aviation, providing the necessary power for longer, faster flights. It is a higher grade compared to domestic kerosene, has a high freezing point of -58 degrees Fahrenheit or -50 degrees Celsius, which can be experienced in upper atmosphere. Also, it has high flash point to reduce fire risk, and any water suspended in it is removed during processing to avoid blocking fuel lines. It is environmentally friendly in terms of carbon emission too. 6. Flight controls. Also called fly-by-wire, it is one thing to get an airplane into the air. It's another thing to control it effectively without crashing back to Earth. In a simple light airplane, the pilot transmits steering commands via mechanical linkages to control surfaces on the wings, fin and tail. Those surfaces are, respectively, the ailerons, the elevators and the rudder. A pilot uses ailerons to roll from side to side, elevators to pitch upward or downward, and the rudder to yaw port or starboard. Turning and banking, for example, requires simultaneous action on both the ailerons and the rudder, which causes the wing to dip into the turn. Therefore, flight controls are a very important part of an aircraft. 5. Aluminum and aluminum alloys. In 1902, the Wright brothers flew the most sophisticated aircraft of the day, a one-person glider featuring muslin, skin, stretched over a spruce frame. Over time, wood and fabric gave way to laminated wood. However, it eroded easily and required regular maintenance. By the 1930s, almost all aviation designers preferred all-metal construction over laminated wood. Steel was an obvious candidate, but it was too heavy to make a practical airplane. Aluminum, on the other hand, was lightweight, strong and easy to shape into various components. Fuselages bearing brushed aluminum panels, held together by rivets, became a symbol of the modern aviation era. But the material came with its own problems, the most serious being metal fatigue. As a result, manufacturers devised new techniques to detect problem areas in an aircraft's metal parts. Maintenance crews use ultrasound scanning today to detect cracks and stress fractures, even small defects that might not be visible on the surface. 4. Autopilot. In the early days of aviation, flights were short, and a pilot's main concern was not crashing to the ground after a few exhilarating moments in the air. As the technology improved, however, increasingly longer flights were possible, first across continents, then across oceans, then around the world. Pilot fatigue became a serious concern on these epic journeys. How could a lone pilot or a small crew stay awake and alert for hours on end, especially during monotonous sessions of high-altitude cruising? Enter the automatic pilot. Invented by Lawrence Burst Sperry, son of Elmer A. Sperry, the autopilot or automatic flight control system and the above problems are solved. 3. Pitot tubes. Invented by a Frenchman Henri Pitot for measuring speed of water flowing in rivers and canals, it was adopted by aircraft engineers to measure airspeed. They are holes mounted on aircraft fuselage or edges of wings. Measuring airspeed is important to enable keeping the plane speed at a required level. It happens that a very high plane speed can cause structural damage while a very low one can make an aircraft to stall and fall down to earth. 2. Air traffic control. It is a system that ensures aircraft can take off from one airport, travel hundreds or thousands of miles and land safely at a destination airport. In the United States, more than 20 air traffic control centers monitor the movement of airplanes across the country. Each center is responsible for a defined geographic area, so that as an airplane flies along its route, it gets handed off from one control center to the next. When the airplane arrives at its destination, control transfers to the airport's traffic tower, which provides all directions to get the plane on the ground. Radars collect aircraft information such as its identity, altitude, course, and speed in a given airspace and transmits it to air traffic control for further processing. 1. Landing gear. Landing a commercial airliner seems like one of technology's most improbable feats. A plane must descend from 35,000 feet to the ground and slow from 650 miles to 0 miles per hour. Oh, yeah, and it has to place its entire weight, some 170 tons, onto just a few wheels and struts that must be strong, yet completely retractable. Is it any wonder that landing gear takes the #1 spot on our list? Regardless of configuration, strength is far more important than weight, so you'll find steel and titanium, not aluminum, in the metal components of a landing gear. Thanks a lot for watching this video. Please like it and subscribe to help our channel and community grow. Stay safe.